While the world waits for Betelgeuse's final act, scientists are racing to learn as much as they can. Every pulse, every shimmer of light, every dust plume tells a story. It's like watching a slow-motion explosion frozen in time, an ancient giant groaning under the weight of its own destiny. Telescopes around the world, from Chile's Atacama Desert to orbiting observatories like Hubble, JWST, and Gaia, are all aimed at this celestial titan, capturing data, measuring variations, and modeling what's to come. Each of Betelgeuse's surface tremors is a clue. Each mass ejection, like the one seen in 2019, is a whisper from deep within the star. These are not random outbursts, they are signs of a star losing its grip, running out of fuel, and preparing for the inevitable collapse. Inside, nuclear fusion is shifting gears. Hydrogen is gone. Helium is burning. Carbon and oxygen are taking their turn. Eventually, the core will forge iron, the element that marks the end. Iron doesn't release energy when it fuses. Instead, it steals energy. And that's when gravity takes over. In a fraction of a second, the core will collapse. The outer layers will slam inward, then rebound outward in a colossal detonation, the supernova. A brilliant flash will tear through the star's atmosphere and illuminate the cosmos, reaching Earth centuries after the explosion actually happened. The shockwave will travel at a significant fraction of the speed of light. But by the time it arrives here, it will be harmless, just light, awe, and wonder. Astronomers estimate that such supernovae happen once or twice per century in our galaxy. Yet no supernova this close, or this massive, has been seen in modern times. The last visible supernova in our galaxy occurred in 1604, known as Kepler's supernova. It lit up the sky for months, even visible during the day, just like Betelgeuse's explosion is expected to be. But Betelgeuse is far closer than that. Its explosion would not only be historic, it would be unforgettable. It might even change the way we look at the night sky forever. Imagine walking outside and seeing a second moon hanging in the sky, not moving, not rising or setting, but fixed in Orion's shoulder. That bright spot would be the death of a star, a cosmic funeral witnessed by an entire planet. It would inspire a new generation of scientists, philosophers, poets, and explorers. For a brief moment, all eyes on Earth would turn upward. And Betelgeuse wouldn't just leave behind a light show, it would leave behind a neutron star, or maybe even a black hole, depending on its final mass. That remnant would remain hidden in the darkness, detectable only with powerful instruments. Meanwhile, the explosion would scatter heavy elements into space, seeding nearby interstellar clouds. These materials, carbon, oxygen, iron, would eventually cool, condense, and form new stars, new planets, and perhaps even new life. In death, Betelgeuse gives birth. This is the cycle of the cosmos. Stars are born, they live, they die, and from their remains, new worlds rise. We are here today because a supernova exploded billions of years ago, creating the ingredients for life. In a very real sense, we are made of stardust. So as we wait for Betelgeuse to fulfill its destiny, we're not just witnessing a star. We're witnessing our origin story, written in light. And when that day finally comes, whether in our lifetime or in the distant future, Betelgeuse will remind us of our place in the universe, small, fragile, and temporary, but deeply connected to the stars above. So keep watching. Keep wondering.